Hello, Clojurians. I'm recording here an intro to a new series of interviews, as we're calling them, that the community, the scicloj community, will be doing over the next period of time. Uh, the idea here is just to explain quickly what we hope to achieve with this interview series and kind of the content. Generally speaking, the idea for the interviews arose out of a recognition that people are functioning and working with Clojure in the space of data science in any number of ways, that there isn't a lot of consolidation or documentation about the ways in which people are working, and that things remain very diverse. And in that spirit, what we thought is that we could hold a bunch of interviews in which we talk to people that are actively working in the with Clojure and data science, and kind of through the miracle of video chats and screen sharing, look at the way in which they work. How do they actually set up their tools? What tools are they using? What we're building, and very pragmatically and concretely, what problems do they solve for them? We thought this view into the screen share, in particular, that would allow us to show how people are working, would give people a lot of insight and maybe help actually build some consolidation around certain practices for using Clojure in data science. So that's the general idea, and we hope you enjoy these interviews. Thank you.
Okay, what I want to do is I'm going to give a kind of a history of how this thing came about. I don't think it'll take very long. And then that will kind of lead into fooling around with the template and the transformation stuff. And along the way, we'll see some of this tab structuring capability. You'll just be able to just see it by default. And then I want to show some of the more experimental stuff that's going on. And in the process, show some interaction with the with graphics and stuff.
Nice.
And that's kind of the basic idea that I had to try and at least give an overview, kind of an idea of how the thing is used and whatnot.
Okay. Yep.
My guess is since this is all kind of experimental, not just the software, but the meeting.
Yeah.
We're going to learn a bunch of stuff along the way, and maybe we can make the next ones for other people, or do some more with this again. Who knows? Better.
Yep.
Okay, so.
One thing also, we might just, when we start, we might just spend a little bit of time, since it's the first, sort of describing what we thought of as the general idea for these interviews, namely to, given that there's a lot of diversity and people working in different ways in the Clojure world with data, one of the ideas for the interview was, or these kind of interviews, was to show a little bit, to get a real view into how people work in their own environments with the tools, in your case, that you've created, so that people get a sense of how people are working, in their editors, etc. This kind of came up because I'm a beginner data science person with Clojure, and sometimes people were talking in various chats about using the REPL as opposed to notebooks. And a lot, and this is a conversation I was also having with Daniel, is like, well, what does that actually look like when people are doing that? I can imagine what it looks like, but what does it actually look like? How are they setting up their environment? How do they manipulate that space? Sometimes being able to see that very concretely is good. I think maybe the kind of community and stuff around JavaScript that exists, where there's just so much content, like really working through some of that basic stuff is what we're getting at.
Yeah. Part of the issue with that, I guess, is that to some extent this is changing. Having a lot to do with this experimental stuff that I'm fooling around with.
Mm-hmm.
And actually that kind of fits with this history stuff that I want to talk about, because that's sort of like, why did you even bother with this anyway?
Mm-hmm.
So that's sort of my take on that. I mean, I can show some, general interactions. I plan on doing that.
Yeah. I think that all sounds really good. Maybe one thing just to keep in mind is, like, if you can also imagine, the experimental stuff is all really good. Like, imagine that, this is somebody who maybe isn't super familiar with Clojure and is like a beginner, and they, like, how would they get into using the tool? If there's ways that you can sort of give that easy on-ramp, it might be good. Also in terms of promoting the tool.
Yeah, we can attempt to do some of that as well.
Okay.
Right. Okay, so let's just jump in and see what happens.
Yeah, let's get maybe a quick introduction about yourself, and then you can tell us about the tool and the history. That'll be great.
Okay, so about myself.
Yeah.
All right. Well, okay, so I'm formally trained as a mathematician, but I spent pretty much my entire career doing computational stuff of one sort or another. A lot of it was in AI, natural language kind of processing stuff.
Mm-hmm.
But then I kind of got out of that around the early 2000s. And I noticed that a lot of interesting stuff with this new biology that's going on has a lot in common with the kind of things that were being done for semantic analysis and parsing and this, that, and the next thing. So it's an interesting thing to jump into, and I've sort of been, I guess my current hat is well, not my current hat. My current hat is a different thing. is a computational biologist.
Uh-huh.
Oh.
So that's, and what I end up doing is genome analysis. A lot of it is high throughput sequencing analysis. So there's a lot of big data involved, and a lot of it can be, you can make a lot of useful graphics, charts, graphs, whatnot. And in particular, dynamic things that are interactive. A lot of, okay, so anyways, that's kind of my thing. And I guess I don't know what else to say. Part of the reason for this, like, I had a hard time with this thing, is I tend to do film stuff on the weekend, so that's my kind of avocation, I guess.
That's the hat you're currently wearing.
It is. Yeah. So at any rate, so actually that's probably a good jumping off point for this history stuff, because in the beginning, when I first started working on these sorts of things, this computational stuff, there was things like Plotly and high charts. There was a lot of JavaScript.
Mm-hmm.
There was some kind of attempted to do some swing-like things, and when I started using Clojure, I tried Incantor. None of these things actually were particularly handy or convenient, to be honest with you. And so there was a lot of hand rolling of things in the old days. The old days being like 8-9 years ago, and we used like D3.
Yep.
Literally just using D3 manually in JavaScript.
Mm-hmm.
And then I sort of came across Gorilla REPL, and it was like, well, this is, yeah, I know it's a notebook-like thing. I'm not a this is probably another piece of how this thing came to be. Not a huge notebook fan, at least not the way notebooks are currently kind of conceived. I've never been a modal kind of a guy, so I'm not a Vim person. Maybe a Vim person would be more keen on notebooks. I'm not sure. But the whole interaction, where you got to click on things and fool around with it, and it goes and changes mode. It's like whatever. And then, you know, and then Gorilla Repo, cool as it was, had a lot of limits. In particular, in terms of actually doing, you know, good graphics. But one thing I noticed about Gorilla Repo is that he was using Vega as the declarative language to do these visualizations, and I was like, this is really nice. You know, there's just something really kind of neat about this thing. It's kind of like ggplot, which I used a lot in R when I do, and I still use that. I still use that kind of stuff for any kind of static thing. So I like generating PDFs, and if you can make a really nice environment for this kind of stuff if you use you know, knitter and log, and you glue those things together so you have the code in mind with the document and all that, and you just generate these things. So I've done a few papers like that, and it's a really nice way to go if you're just doing the static kind of stuff. But one of the things we really wanted, especially in those early days, was all this interactivity capability, because the biologists want to be able to dynamically explore the data. You pop up a ggplot, it's like, yeah, that's really cool. It has a lot of nice stuff in it, but you can't actually do anything with it. And if you're dealing with thousands of data points, it becomes even more painful. You just can't. I mean, you get a picture and you sort of, well, you know, you can maybe get an eyeball of, you know, this experiment didn't work at all because the data is just wrong, just looks bad. But other than that, you can't do anything else. You can't investigate how different genes are interacting with one another or any of this kind of stuff. So it was very much this idea of having dynamic things that was a big piece of it. So one of the things I stumbled upon earlier, because I was really doing this Vega, kind of the Vega promoter, was this, I think it was called Gypsies. And it was a pretty neat library that did a lot of kind of neat things out of the box. And I used that for a while. And it's a client server setup, JavaScript on the front end and Clojurians back end. And the way you got to try to get, I mean, I don't know, it really, it's not as bad as V3, but it's, you got to put a lot of stuff in it in order to make it do anything. So even like a bar chart or something, there's a bunch of stuff you got to do. So one of the nice things about Gypsies was it had these pre-canned things for scatter plots, line charts, bar charts, whatever. And that was pretty cool. Except then the first thing I said, but gee, you know, I just get tooltips. And it was like, no, you can't get tooltips. You get tooltips if you take the map that it generates and then kind of hand hack the tooltip channels into the output. And I was like, okay, you know, that's whatever, not the greatest. Then I was casting about for more stuff, and I ended up stumbling upon this Ulebot thing, Wizard, which used Vega as well. And I was like, well, maybe this is a little better. But it turned out that it was actually, in many ways, much worse. Both of them, though, I think Gypsies did this too, used Saite. And it's just like, Saite brings an enormous amount of baggage, you know, boatloads of stuff, and the only thing you really want out of it is simple WebSocket messaging. That's it. You pull all this other junk, and it's just way too heavy weight
Mm.
for this very simple thing. So I didn't like that. And in addition, it didn't really have much more interactive capabilities either. Then there was a later version of it that ended up being Vega Lite. And then what happened there is for reasons not entirely clear, they took the Vega support out. So it was strictly Vega Lite. And I was like, well, that's okay, but Vega Lite has these limits. You can't do like things like contour plots and other stuff. And so it was like, well, I don't know. There's got to be something else. So I started messing around on my own, fooling around with this. And the first thing I decided, well, I got to have a better message. So I just got to have a simple WebSocket-based messaging framework that's pretty agnostic about domain semantics and has the capability to let you build any kind of thing you want.
Mm.
So I kind of had a version of that working with some basically kind of did about the same thing as what as Wizard did, but with a much simpler base. It was a lot simpler, including this, even the reagent stuff. All of that Wizard stuff was based on old, obsolete, deprecated React and reagent and all this stuff, and it was like, well, this is not very good. And then I noticed Oz came about, and it was like, okay, maybe I should look into that. And it turned out that Oz, though, was really just Wizard with Vega put back into it. I guess Christopher Small thought, he needed Vega for things like contour plots and whatnot. And that's all it really was in the beginning. It was just basically the old version of Wizard with a new name. And then he added a few more bells and whistles. But again, it was all very static. It didn't really do much in the kind of thing that I wanted. So I decided, okay, I'm just going to keep pushing on this a bit. And the more I sort of fooled around with it and building visualizations across a lot of data sets, these data sets are, I don't know about other people, but in this field, a lot of times these data sets they're similar, all right? So there's a lot of characteristics of the graphs and charts that really can be abstracted out, if you will, so that you can just use a kind of base and then plug in different things. It's not just the data itself, but there's different fields and things like that. But the structure, basic structure, is very similar. And so I found myself writing these Vega Lite things that would take like 2 pages and then cut and paste and change some of the fields. And it was like, this is no good. This works, but it's a recipe for lots of errors. Painful and everything else. And so it's like, okay, I guess I better do like what the Gypsies guy did and build some functions that abstract over some of these things and whatever. The problem with that is just like in the Gypsies thing, the first you build something like that, and the first example after you do it that comes along doesn't fit. There's stuff that I guess I need to account for that field or that sub-component or whatever it is. And it was like, why it became, and as I was noodling on this one day, it came to a point where it was like, okay, this stuff is all data. Why not? It seems like the best way to deal with this is to have data transformations.
Yeah.
And that's where this concept of these templates came from. So, okay, why not? In the beginning, they were really simple. There was not a whole lot to them. It was like, well, gee, I just can put in some markers for the values of various fields, and I'll just substitute them with a hash map.
Yeah.
So you have a a starting hash map, and you just transform it with, you know, these markers being given values, and then you just swap the keys. So that was like, well, that happens to work pretty nicely. And then it dawned on me that, well, gee, I could do much better than this. You can just keep going until you can have entire plots and charts and things like that defined in terms of these abstracted template components. And that's kind of how it came about. And that's pretty much how that whole thing came about. And then as I decided to, okay, I think I want to make a thing that does this. The other thing that occurred to me is, well, you know, why am I always hand laying out all these things? That doesn't make any sense either. Why can't I build something that just automatically generates all this stuff?
Yep.
And that's how the tab system came about. And, well, it started out as just one tab, which had automatic layouts,
Yep.
columns or rows, and you could have a different number of elements per and all this stuff. And it was, oh, that's great, you know. Gee, maybe it would be kind of cool to have where you could think about almost like a paper or a book where each tab is a chapter or a section. Now you can just have a bunch of tabs, each one having all of this specific information for the chapter or section or whatever it is. And it's a pretty neat mechanism for laying out documents and active documents.
Yeah.
I ended up actually using this thing to give some presentations, and it worked pretty well. So at that point, I decided, well, I should probably just make a library of this thing, and that's where Hanami came from. And originally, Hanami was, I kind of had a struggle with it because it was like, okay, is this a library or is it an application? And so I tore out all of the application bits and just left the library parts. And then I, in order to get back kind of to where I was before I did that, I created this Saite thing. Now, the nice thing about Hanami, though, is you can build all sorts of other interactive one-off applications. So there's some specific data visualization applications that we use now in conjunction with this pipeline thing that I also built. So you just pull these, can go to their data sets, and previously they were all just static GG plots, but now they're highly interactive things that belong to the web. So they're kind of happy about that. But you can just build pretty much anything using that as a base. Anything that, you know, that's covered by things like Vega. Plotting and charting stuff.
So if I were to like summarize the relationship of Hanami and Saite, Saite is kind of built on Hanami as a library, but is a kind of opinionated application context for how you might use this, and for, in particular, presenting information in different tabs, where the tabs are sort of grouped explorations. Is that? Yeah.
Actually, they can be grouped explorations, or they can literally just be like a presentation. Because one of the things that occurred to me was, another thing that was like, well, you know, why am I doing this by hand all the time? It's like if you have a plot and you want to put text around it to explain something, right? Well, you can do that manually by fooling around, you know, embedding the Vega visualization in some hiccup and stuff like this. And that's great, but again, it's all manual. And so that was where this idea of picture frames came from. It's like, okay, why don't we just have the ability to embed a visualization automatically in any kind of text, and potentially well, Markdown for sure, but eventually things like LaTeX.
Yeah.
So now a lot of that is actually in Hanami. It's there if you want to use it. If you don't want to use it, you don't have to. But one thing I didn't include, one thing I absolutely didn't include in Hanami is LaTeX support, because that requires Mathjax or something similar.
Yep.
It's another dependency. It's just painful. So it's like I'm not going to do that. So, but that migrated into Saite, and it turns out using things like Mathjax or anything else that's similar with React is non-trivial.
Yes.
It's
I think most of the web libraries built before React, they don't fit into this new component model that easily, right? That's
the problem is, there was a big discussion about this, and I even in my 2 cents at one point. Originally, it's exactly the same issue as Google Translate. So a lot of these websites use Google Translate to do different things in terms of translation of text, and that totally breaks React as well.
Yeah.
And so there was this huge discussion, and the React people were saying, well, Google needs to change.
Sure.
Like, yeah, okay, whatever. But the part that was so ludicrous is that it came to be pretty clear that the only reason why they couldn't make it work is because they didn't want to, and the reason that they gave for that was okay. What it boils down to is they don't track DOM nodes at the level that they should. And the reason they don't is because they feel they can cheat. And if they cheat, the performance is better.
Mm.
That's really what it boils down to, is performance thing. And the problem then is that they were basically saying everybody who's ever done any kind of transformation out of DOM needs to rewrite their stuff in order to work with us. It's like, well, nobody's going to do that. That's just a crazy idea.
Yeah.
And so what happened is some people said, well, here's all you really need to do. Here's the fixes for React DOM tracing. So what I did is I took that and took the idea and wrote a hack, a little hack that basically runs as the very first thing on page load in Saite, and it fixes the React code so that things like Mathjax don't break it anymore.
Oh.
So that was painful. Yeah, but now LaTeX works in Saite. It works pretty nicely. And it works completely in conjunction with Markdown, with the Markdown thing that I have. And the Markdown thing I have is actually, I can't think of the guy's name right now. It's a very, very small, contained little library, effectively, except that he didn't actually put it out there as a library. So I asked him about it. I said, can I just use this thing? Because it's only like, one file, a couple hundred lines of closure, and it does most of them in Markdown. So it's pretty nice. So that's kind of nice. And because of that, I had to wrap some things around it in order to make it work with the React stuff. But other than that, there you go. And then at that point, I can do pretty much a lot of stuff. Okay, you could use it all from Emacs. You can generate entire documents in one click, kind of a thing. You basically what you do is you take every transformation and visualization request, and you can stick them inside a big do. And even if these things involve dozens of tabs or something, you just make one evaluation and everything gets updated in one whack. And that was, it's pretty nice. But again, I didn't even know. Wow, it's like thunderstorm is going on here. One problem is I don't even know if it is a problem. It's not real convenient to have both. Well, not always. Let's put it that way. It's not always convenient to have, you know, the separation of server and client.
Yeah.
For everything. Sometimes it's really nice to just be able to have it all in one place. And that's part of the idea that came from, actually, you can probably see this tab here, which I'm thinking of is, it's the default screen that comes up when you load Scicloj. And the idea was, this whole idea of this thing was is that you could take snippets. I mean, if you go out and you grab something from Vega, from the, or the Vega examples or Vega Lite examples, and you say, gee, that's what I want that plot, but I want to use it for Clojure. I mean, and then you got to do some hand translation, right? It's not much, but you got to do something. Anyway, so that was kind of the idea of this thing here. You could paste your JavaScript over here, and you could click this and turn the Vega Lite thing into the CLJ.
Yeah.
And then you can immediately use that as part of your template, starting template, effectively, and do visualizations with. Or you could even translate it into Vega first, and then translate that into CLJ and use that as a starting template. That kind of thing. So it was just a quick way to get something up and going. And
So here, the CLJ here essentially is the Eden, right? The maps. Yeah.
Yeah, it's basically Eden. And then I added a couple of things which I don't know how useful they are anymore. I'm not totally convinced of their use now that this newer stuff is in place. But that's sort of what this thing was all about. You can do this nifty translation back and forth. You could go the other way. Yeah, wow. It's really starting to, hopefully the power will stay on. You can go the other way too. If you have a hunk of CLJ, you can translate it into JSON. Use that as get somebody else.
So it'd probably be good to jump into showing how you work with it. Maybe, I don't know if there are like other questions that people want to ask in this kind of intro, like as you relate to the introduction, but I don't know, one I have is just, what is what's the Clojure context adding here? And, or, how do you think Saite and Hanami kind of fit into the broader domain of tools around data science that exist in Clojure? I think one of the things we're interested in a little bit is kind of, scoping out what exists in the Clojure verse for data and and how these different tools relate.
Right.
So I don't know, maybe there's something to be said there before we look at how you use this thing.
Yeah. I mean, that was a good question, and I think it's mostly a case of what's the point of using Clojure for data science at all after I got Python and ARM. And I think that's a legitimate question. I just happen to like Clojure a lot for the basic data manipulation capabilities and stuff.
Yeah.
Put it this way, writing glue code, if you will, in Clojure is a heck of a lot nicer and much more robust than hacking it in Python or R.
Yeah. So
that's a potential, that I suppose is the primary potential reason to even pursue this kind of stuff. And after all, you do have things like, I don't like stuff like Jupyter or even Gorilla REPL for that matter, because of this notebook kind of conventional scheme that they have. I don't know if you guys have looked at Iodide at all.
I haven't.
Okay, well, that's something out of Mozilla, I guess.
Huh.
And when I saw that, I said, that's really interesting because that's very similar to this stuff, this newer stuff that I was experimenting with in Saite. And the idea there is you basically have effectively the markdown in one pane, and then the updating document in the other one.
Yeah.
And you can sort of switch back and forth with these modes. And they had the ability to do things like JavaScript and Python. We talked about maybe some other stuff. And their entire approach, though, is a little unconvincing in some ways, is that they were doing everything into WebAssembly.
Yeah.
And which is great, except well, I mean, if you need more computing power, then that's going to be a problem, right? I mean, even if it's all turned into like C code or something under the covers, or you take the C code and turn it into WebAssembly, and then you generate machine code from that. The problem is that you're still going to have some issues, I think, if you need access to a bunch of different machines, or you need access to file servers, all this kind of stuff. So, but it's an interesting idea. I think it looks kind of cool. All right, so some of this is going to show some of the new stuff anyway. But what I wanted to do is just go over templates.
Yeah, that sounds really fundamental to the project.
It is, because that's kind of how you make everything kind of work in a kind of interesting way. It's one of the things that I think is actually much better. Let me make this. I don't know if oh, wow. Okay, you guys are still there.
Yeah.
Okay. By now, this should be the whole screen, I think.
Yes.
Yep. Okay, great. But this templates are really kind of nifty because they do this nice level of abstraction that I think works. Is that it makes them every bit as concise as something like Altair, which is the Python support for Vega Lite that the Interactive Data Lab people themselves provide. So it's the primary programming language binding thing, if you will. And it's pretty neat, and it does do this abstraction over Vega Lite in the way that I would like, except that it has the same kind of an issue where they have a bunch of methods. And anytime anything changes with respect to how Vega Lite works or anything, they have to go in and update all that stuff. And if they want to provide other abstractions, they got to write that. They got to write code, as opposed to just doing data stuff. Okay, so let's just take a quick look. So, 1 second. I have to close a window. Wow, it's really
Stormin'?
things going crazy. All right, so let's just take one thing about these templates is all they are maps with these things called substitution keys, and substitution keys are the values of your primary keys, and then the value of a substitution key is swapped in as the value of the primary key. Okay.
So that first line is swapping A with X or something? Is that?
It's swapping A with the value of capital X.
I see.
Okay, so capital X is a substitution key. And if there is a value for this key, the substitution key X, in either the defaults or you give it, you can get it, this is a variadic function, so you can give any number of key value pairs, and it'll transform. So what happens then is this will transform this map into A with the value of X.
Yep.
Okay, so if we just execute that, there you go. You say, well, okay, that X is because the default map has capital X as the string X.
I see.
And the reason it's the same thing for Y is because lots and lots of data sets have the X and Y channels that identified as in the data as the field X and the field Y.
Mm-hmm. So what's the default? Is that that's like some data?
Yes.
Is that something we can see, like the structure of it, or is it?
Oh yeah. Absolutely. Actually, we can probably take a look at that if you really want to.
I see.
Yeah, here it is, right here. So this is in Hanami. This is actually a facility supplied by Hanami, but you can change it to whatever you want. And one of the things is that Saite sets some defaults when it starts.
So this represents a set of defaults specifying visualization.
Yep.
Is that right? That in the language of Vega Lite? Is that?
Vega and Vega Lite. Yeah. And you can mix it as far as that goes. There's some Vega, down here at the bottom. There's Vega Lite. I mean, Vega layout transforms. I had to use this stuff for contour plots and trees and things like that. A lot of this
is stored in a ClojScript atom.
Yes.
Browser. Okay.
Yeah, it's actually both. It's on the server and on the client. So you can have client-only Hanami applications.
Yeah.
As long as you can get at the data.
Okay.
So if the data is a URL, then you can make that work.
Okay.
If the data is in files on servers, then you're going to need some kind of server access to it. So you can go client-only Hanami applications and client-server Hanami.
Okay.
And Saite happens to be a client and a server, even though it's a lot of stuff just in the client. Yeah, so that's kind of it. If you look, right, like this is this stuff about encoding. So encoding is a concept in Vega about how to do channels and things like that. And so there's a bunch of defaults for all of that stuff. Most of them you'll see are this remove thing.
Yep.
And remove, so this thing is written using Spectre. And frankly, I tried writing it without Spectre, and it was like mind-numbingly painful. And so I was like, well, Spectre thing, I should probably take a look at it because I think that's exactly what it's for. And it just made this gigantic ad hoc transformer into something really straightforward and simple.
I think once you have deeper data structures, I think it's pretty much impossible if you're doing the transformations using the standard functions.
Yeah, it's so ad hoc. Basically, what you end up doing is reinventing Spectre. So I got rid of that, and Spectre now, and this RMV is actually just a value. A var in Hanami that's set to the Spectre none value.
Okay.
Which is a special thing in Spectre that says basically remove.
Yeah.
Get rid of whatever this thing is associated with. And that's sort of that's a key thing about this transformation stuff and using templates, because it changes how you can do everything. So let's look at a couple more, and we'll see this very quickly here. So here's an example where we had the default, which was little x, but we can change it by just giving a value for x as part of the arguments to it. So if we now do this, we'll get A as food. And if we go down here, since we sort of looked over here and saw the Y piece here, right? So if we see that in the default, what we're going to do is we're going to assign to A the value of X, and X is the map, which also has the substitution key on itself. So when you do this, that's what you get. So you can sort of see that this all kind of makes sense. And the key thing here with this is that you can see that it has to do X, and then it has to go and do the value of X, which in this case involves transforming the capital Y.
Yep.
So read this recursively. All right, so we can we can do this kind of stuff. Interesting. Well, this is a case where, this is a little interesting, I guess. We don't have a substitution key in the default substitution map for this key Saite, so it's nil. And so the value that's associated in this transformation up here is just the key Saite, because that's the value. Okay.
So when it is nil, it's going to use the key itself as the value.
It'll look this up and say there's nothing there, so the thing itself must be the value.
Right.
Okay.
But I can also override that by just adding it in.
Yep.
Oh, so yeah, and I'm just connecting this now, I think, with something you said in the beginning, is that when you, in the history of the development of this, you had started with these long definitions, right? And essentially the long definition here is the defaults. Is that right? And then you kind of keep that or transform it, or?
Actually, not quite.
Okay.
The long definitions end up being the templates. So right now we're just playing around with substitution keys, and the templates for us right now are just these these little hand rolled maps.
Okay.
I don't know what this is here. Very quickly, we're going to see a template thing.
Okay.
Here's another thing I want to show, though. So this is a case, foo's just going to transform into what we were already expecting. But let's go down here, and if you guys have happened to glance over those rules of transformation that I posted of possible prep material, anybody have any idea what this is going to turn into?
Nope.
Okay, well, let's just walk through it quickly by hand. We're going to say, we're going to transform this map of A : capital foo using
the foo is an empty map.
Yes, and so foo is an empty map, so that gets put in. So A will then be associated with an empty map.
Yeah.
Right?
Foo.
But empty things are considered removable things, and they get the special RMD values instead. And so A just goes away because it's associated with an empty collection, and empty collections are to be removed. And that's a big deal in terms of how this can actually work. So here's another example here where the scale has this RMV, it's the specter or none, okay? So if we come down here, we're going to get the same thing. So scale gets removed, and that means this is an empty, that means foo then is associated with an empty map, but then foo is empty, and it gets, the value of A gets this empty map, and so it's empty, and so the whole thing ends up being empty.
And that's valuable because you end up having more consistent or like valid templates in the end? Is that?
We're going to show you right now why that's a big deal. All of these things here have this specter none, right?
Yep.
Like that. This one is a little different. You're going to have substitution keys that are functions. Okay. And they take the current substitution map as one of the arguments. They can, and the key that they got invoked with, and then they can return something more sophisticated. So in this case, this val data thing, what it does is it tries to resolve either data sets that are inline or files. And if they're files, they can be Eden, CLJ, JSON, or CSV.
Mm-hmm.
And it will turn those things into a proper data set for Vega and Vega Lite. So if we do this, we'll see that, okay, val data understands either capital data or capital F data, where F is the file, and so this would then be a file thing. But if we do this, it's going to say, I don't have a data or F data, so I just return nothing.
Mm-hmm.
Okay, so and nothing is empty collection, so that means a val data would disappear if it was part of a map. So now let's look at a fragment. You'll see now why this is such a big and useful deal. So the data options, which are going to be how you supply the data sets to Vega or Vega Lite. This thing defaults to values as being val data, URL, view data, name, and data. And data name things are Vega data channels, special channels that you can feed things into, URLs or just URLs. And this is either inline data or a file that gets turned into the data set.
The basis for the plot, or
right. It's the actual data that makes the plot be anything.
Right.
If we transform these data options, okay, the data options itself, now that we know what we already know, what are we going to get? We're going to get data, because all these things basically go to empty, removed, and so it's removed. This one goes to empty. These are removed. This being empty gets removed because that's how that's defined. And here's why that becomes useful. If we give a value for data, we now have a valid data option that fits the specification of Vega Lite. All these other things disappear. And we can do, and if we give it a URL, we get the proper one for URLs.
The transform can take more keys and values, right? What happens if you give data and udata?
Well, if you do that, my guess is you're just going to get
I think it applies from left to right, right?
Yeah, what's going to happen then is Vega is going to give you an error.
Okay.
Yeah, if we do something like that, like data. Yeah. So what's going to happen here is you'll get a compilation.
Because at that point, Vega doesn't know where it's which one do you want, basically.
No form channel. Okay, so let's go on a little bit further with this, because you start to see how things build up. So originally I had point charts and bar charts and all that stuff. Abstract out.
I was thinking the right-hand side is uneditable, but this is super cool. This is much better.
Say that again?
I was thinking the right-hand side is uneditable. It's only the output, so you can actually edit that stuff as well.
Oh, yeah. Actually, both of these, this is probably worth mentioning. Both of these panels here are code mirror editors.
Ah, okay.
Okay, so Saite pulls in code mirror and uses, right now it's Emacs and it's Clojure, the language. Yeah, there you go.
Nice.
This is the output area, but it is editable.
Yeah.
And what's the reason for that?
The reason for which?
Why is it useful that the right-hand side is editable?
I don't know. To be honest with you, it's I don't know that it is necessarily. You can't actually evaluate anything over here.
Right.
It's just that it inherited. It's literally the same type of code mirror panel.
Mm-hmm.
Okay.
Clojure Emacs enabled panel.
Mm-hmm.
Yeah.
Nice.
Yeah. So that's, yeah. Except that you can't actually evaluate anything.
Right.
Yeah.
Actually, I don't know what would happen if I tried to do that. I don't want to do that right now.
Let's not
Yeah.
break the thing.
Okay, but here's the deal is now you have a subcomponent, this thing called view-based. They used to have all this junk in individual plots, plot definitions and whatnot. It's like, well, that's crazy. Why am I doing that? Because this stuff is just the same thing over and over and over and over again. So I abstract that out into a thing called a view-based. So Vega, if you guys are familiar, Vega Lite based on Vega, and Vega has this concept of views, which are composed of layers. And a view is basically has all of these kind of characteristics that's defined. It has an encoding, possibly has a transform. Has the this user meta thing is something that was really nice from the IDL folks. They knew that, well, various applications may have user-specific data that they need to communicate.
Yeah.
It gets pre-processed before the Vega and Vega Lite gets their hands on it, and so this meta key is effectively supported but ignored, and so you can put anything in there you want. And in particular, you can put control information in there, and that's sort of how Saite uses this stuff. And then you have, things like width and background, titles, the data channel, and all this kind of stuff. Okay. All right. So let's take a look at encoding. All right. So encoding is a big deal because it contains a lot of information. So if we get the default, so we're going to pull it out of this thing here. We can just query the value. And there's a lot of junk in here. And as you can see, there's a lot of, again, substitution keys. So this, again, with this recursive transformation goes on. So encoding will be replaced in view-based with this thing, and then all of these values get transformed and so forth. So, okay, so one thing is okay, so what happens if, it would be better to go full screen. Let's literally transform encoding. There's a bunch of defaults for it. What do we get?
Oh, interesting.
There we go. So
A lot of stuff disappeared.
a lot of stuff disappears because a lot of stuff has the RMD.
Right.
Yeah. And so this is your basic encoding. If you don't supply any of these other capabilities, this is what it is. All right, how about this user data? That's the thing that we were talking about. It has control information. So let's take a quick look at that. So there's all this stuff. Quickly go over this. This is for specifying the structure of tabs. They have IDs, they have labels. Turns out that the default thing for labels actually transforms the ID into a capitalized string. And it has a bunch of options. In terms of things like, is it row order, column order, how many elements per row or column, this kind of stuff. You can have a user wrapping function in this thing, which basically says after I do all of the formatting, you can encase my resulting grid into another pickup thing or something. So it's a function that takes the grid layout and then you can do encase it in something else. There's this frame stuff, which defines picture frames. There's top, bottom, left, right, and then there's frame ID, which is really useful for some of this more experimental stuff where you can add things and pull them out and change them dynamically. There's a bunch of options. They have things like what is the mode? Is it Vega, Vega Lite? What's the renderer? Stuff like that. Message app is for the server. It's like, what's the default message that I typically want?
Yep.
And all that kind of stuff. All right, so if we now so let's transform that, and we'll see what a lot of all the default keys for that stuff are. So there we go. So the default has the ideas explored 1. Here's how it got turned into the capitalization, because this TLBL, capital TLBL, is a function which eats the key and then doing something based on the current transformation map. Here's the options. And there's a bunch of other stuff here. Here's the renderer. The default renderer is canvas. Mode default is that. All right, so I don't know if we really look at this. Well, let's just quickly do it. So this is the function. Here's how it's defined.
Yep.
And so if we just do a quick, we already know that that's EXDL, and if we apply the function, and so what we're going to get is that. Yeah, so that's how that works. So now if we, let's do this. I just didn't want to do that. Actually, let's clear this thing. And let's go back. Here's our view base. And if we just do a transform on it, that's what we get. This is very close now to a legal Vega-like specification. The only thing missing is we don't have any data.
The data, yeah, that's amazing. Yeah.
So we can fix that by just adding a data set. And now we're done. So this is actually a completely legal data specification that can be rendered.
Yeah.
And let's do a quick, we're almost there.
No, it's nice to see how it's building up.
Yes.
That's really,
And so now point chart is basically just our base encoding with a type, with a mark, with this mark.
Yep.
Right? That's everything else is the same, and so that's even how it's defined in the template. Basically, view base with a mark, with a point type. So if we now transform this thing, we get, there you are, and that's a complete art that can be rendered. In fact, we can even render it. Let's do that. And we're going to do it. We'll do it from the server. How's that? So here it is. Basically the exact same.
The same code. Okay.
Exact same thing.
Yeah.
And if we do it over here, we'll get it comes up the bottom. But I mean, it's the same
map.
Yeah.
Yeah.
And all we got to do now is just send it. Send it to the server, I mean to the client. And here we are. Here's our tab. Then we can go back over to this tab where we still have everything and we're doing whatever we're doing. But there you go. That's the rendering of that thing. And you can do this. You can just keep adding to these things here. Let's look at this one. Here's
so just quickly, if to go back to that where you were building stuff up, the CLJS or that. So just, and I think this is maybe other people is clear, but so on that last thing where you generated what was not then a renderable template.
Yep.
Basically, point chart is just view base with that one thing set.
With that mark.
Right. And then you're just adding data and replacing the keys.
Yep.
Yeah.
That's it.
And then when you're sending, so, and then the step where you sent it from the server, at that point, you're sort of specifying a graph on the server side so that when you reload this client, it knows to render that in a tab. Is that right?
Not quite, because what happens is you're not reloading anything. What happens is this SV thing here, this this thing here,
right?
That is a thing. It's just a little abstraction over sending a message.
Oh, okay. You got some. I see. Right. That's the messaging framework you mentioned earlier.
And here's this message op.
Mm-hmm.
This is what gets caught.
Oh, it says create a tab when you get a message. Is that what that means?
It says create or update. If it already exists, it'll update it.
Uh-huh.
And the other thing is you can specify an entire sequence. It doesn't have to be just one chart. You can have 100 charts and send them in one whack, and they could all be associated with different tabs, or some of them in some tabs, some in other tabs, and it would all just in one whack, and you would get them all.
So it's basically sending a message on WebSocket to the client.
Yes.
Yeah.
Yep.
And what would it mean to? You said it was also possible to render on the client.
Yes. Yes, indeed. Indeed, we can even look at that.
Okay.
That's actually some of. If you build a one-off, you can do that. But this, let me show you some of this then. Okay, let's go over to this chapter 1 thing. All right, so here's a bunch of stuff that's in here. The idea is we're just going to. So this is effectively this thing I was talking in the conversation I had with Daniel. Like, what I would like is now to be able to do. It's not there yet, but I mean the idea would be have a comment with, and then you have, well, this is CLJS. It's not CLJS, something like that. And it would be demarcated, and you could use, and the nice thing is, just like way I have built up the keys, I can probably show you that. Here's, I don't know, can you see this entire thing, or is it blocked?
No,
we can see it. The font's a little small, but
okay, yeah.
I don't know if it's possible to increase it. I mean, I can read it.
Anybody remember how you do that in Emacs?
Control X, Control plus.
Control X, Control plus. Control X. Control X, Control plus.
There you go.
Yeah.
Yeah, that's better.
Yeah. So this is some of this experimental stuff in Saite. But let's go over to Clojurians. And the key, and the deal is that you can create your own key maps, right? Or you can update key maps. So like I said, this has a default Emacs key map, but it didn't have any CIDR things or anything like that in. So,
you're sending a message from Emacs here? Is that the idea?
No, this is
code mirror configuration.
It's code mirror with Emacs bot. You can.
Oh, I see.
Yeah, actually, like right down here. You can,
I see you setting that.
This is the call to code mirror. So this is a reagent third form React component, and that builds these code mirror themes. And right now I'm giving Emacs as my default, and the extra keys are the CIDR keys.
Yep.
Yeah.
And so just like I can do Control C, Control C, Control C, Control X, Control E kind of stuff in this world over here. So if I just put my cursor here and I do I can't use Control C, Control C is ate by the browser in some weird
Yeah.
So I remapped it to control X, control V.
Mm.
Uh-huh.
Okay, so, but you wouldn't have, the idea is you wouldn't need this add to body. You can make this simpler. You know,
Right.
you can get rid of some of this stuff.
Uh-huh.
And you use the code mirror to do this. You would say, oh, look up, find this thing, find the block, find the beginning and end of the block, find out what kind of thing it is.
Uh-huh.
So let's just render a graphic. Okay, we're going to render a graphic over here. There we go. Tooltips and whatnot.
Uh-huh.
And then we can,
Nice.
yeah, we can add some more. What did I do? Add some text. Let's make this bigger. I guess what I'm saying is, well, you know, and this is with Markdown.
Yeah.
And it's for the, here's the picture frame left, picture frame top, picture frame right, picture frame bottom.
Mm.
Let's just get rid of it. And then let's, I don't know.
Interesting.
Bigger, different, bigger, something, bigger header left or something. I don't know. So you can just keep noodling around like that.
Yeah.
Yeah.
And then here's some, we can just do closure kind of stuff. So we'll generate some data.
Mm-hmm.
And, here's the output window for this thing.
Okay.
Nice.
Look about it. But there's the data set. And then you say, okay, let's add a chart. And then this thing scrolls.
Yeah.
Look at this. And it's more right up.
Yeah, this is interesting. So I think I'm starting to get a sense of, I don't know, it's a conversation I had with somebody where, you know, around why people in the Clojure world around data science seem to be a bit frustrated with the notebook context and prefer working in the REPL. And it sort of feels like here what you've done is try to bring that together a bit, add a little bit more, you know, sort of multi-axis places to work, which instead of that straight linear notebook, you know, which can be pretty limiting.
Exactly. And this grid over here just happens to be the else curve. I think this is row order, and it's one element per row. If you reset it to 2, this thing would have been over here.
Yeah. So you can control the layout and everything.
Yeah. You can. Yep. And then we can even define another function. And then let's sort of, here's a bunch of, so we're going to say, well, let's change the bottom. Let's change the bottom of this thing, which if we go up here, we'll see that it is. Yeah, here it is. So the frame ID is, that's that frame ID. The same thing here. So if we do this, hopefully it'll work. And I guess we did. Unsupported escape. Oh, this is something that's different on the Mac. I don't really know why. Let's show you this though. Maybe this is kind of interesting. How does this work? Yes, we can do a replace. So
nice.
actually kind of cool.
Oh, that is nice.
And then you can just do an all. I mean, so it's like a real editor. It's not like
Right.
like Gorilla REPL was hopeless for me. There we go.
Yeah.
Nice.
Oops, screwed that up. Need to have. This is another thing. It's different on the Mac than on my Linux box. So actually, literally, you can put these. I don't know why. It's the same thing with these double backslashes. You don't need to do that on the. There we go.
Right.
Nice.
Yeah.
That's very cool. So, and what would you say is the scenarios in which somebody would choose rendering from the server versus what you've been showing us here in terms of playing around? Is it, with the client, is it kind of, I guess maybe the client context is good for live presentations or maybe when you're in the exploratory stage yourself, whereas you'd put it on the server when you kind of had worked it out? Is that?
I think partly. The other big thing about the server is the client doesn't have access to, file data sets.
Oh, right. Yeah.
I mean, if you stick them on URLs, you stick them in URLs, that can work, but a lot of times, for example, I know that in the labs that I'm at, they don't want to have their data on public servers. Like an AWS. Well, maybe if it was private, it would work. I don't know. I know that they're like
wary of that.
Yeah, until it gets published, then they don't. So there's that kind of an issue. The other issue is, this gets back to some of the discussion I had with Daniel. I mean, there's no reason. Okay. This interaction here is part of this thing with this @ CLJS thing, is that you could have an @ CLJ. And it says, oh, that means this thing needs to go talk to the server to get it.
Yeah, right, of course. Yeah.
And the reason you might want that is because of file data sets. So instead of if you didn't have this, if you didn't have like inline data here, like this thing, or a URL data, but you had an F data. I got to go get that from the server someplace. But the other thing is it would be cool if you had that, you could have Neanderthal.
Yep.
As part of the computation in this thing. So, for example,
what is Neanderthal?
Neanderthal is a
GPU acceleration level.
I see.
It's a matrix linear algebra.
I see.
It's on top of a glass and LogPack, and it's a really, really nicely done framework. There's some really, really cool, I don't know if it's a framework, maybe it's just library. Anyways, you can imagine like this simple distribution thing that I have here, right? Maybe this thing is a major, it's something that takes a lot of computation, let's say. And you want to be able to do it in a kind of interactive way. Well, using Neanderthal to say the computations that they were in theory, in many, many cases, you can do it, huge data sets in just a couple of seconds.
Right.
It becomes viable. I mean, if you were to do it in Clojure, it might take several minutes or something.
Right. Yeah.
So the scenario there is that you would be sending, you do the computation on the server, even though you're kind of messing with it in this more dynamic client-side way.
And then you send the results back.
Yeah. And that currently isn't possible because of that, or is it?
I'm not sure I understand.
I mean, currently, is that possible to do that, to use Neanderthal in what you have here? Or is that something that's like a future?
I can do it if I'm pushing from the server. Right?
I see.
I can't do it this at the moment.
I see.
Yeah, it doesn't have enough brain to do that.
Right.
But that's the idea. And then the other thing is you know, you get all, you can sort of structure this, you know, across these tabs. This is another thing that's sort of interesting. So here's a simple bar chart. There are things that you can't do in Vega. This is not one of them, but it's an example. This is actually not part of this Vega visualization at all. It's an ancillary component. It's a recon slider bar, but it's attached to the data channel. So if I change, I can do my sliders here. And so what's really cool about this is there are things that you really just can't do in Vega at all. For example, if you have a big, had a really big, let's go back. We can do something. It's not really the example, but it's good enough. Now let's go back to this thing for a second. So suppose you had way more than this.
Yep.
And you were trying to do some sort of interactive thing with a brush, and maybe you could highlight some things. But suppose you knew that you were looking for gene ABC. You know, how is it being expressed differentially in some plot? If you've got, you know, 5,000 points, you can sort of mouse over these things, but it's going to take forever, right? So it would be really cool to have an input box where you type in the name of the gene and then the thing lights up. Because it turns out you can't actually do that in Vega. And I talked to the developers and they were like, well, you can't do that right now. Not that we can't add it, but we're not interested. It's a low priority. We don't need that. But on some of the stuff that we were doing, I was able to create a little application that 8 data sets and was able to do that. You had a little type in box and you can highlight your genes however you wanted, and without having to try and find them manually. Yeah, so stuff like that. So you get these ancillary components, and it's nice. I mean, I don't know if any, you know, for myself, this recon stuff has been a godsend because it does all this flex stuff, and which I find rather inscrutable. I tried reading on it a couple of times, but it's like I don't think I understand how this.
It never sticks.
It's a very, it's different. That's for sure. I don't know. I don't even know what I did. This is some of the stuff I showed the Boston Clojurians Zulip. I don't know what this. Okay, yeah, it's like here's. You get your overview plug. I don't know what this is. Does that. You know, your overview plug detail.
So that's one of these examples where you're not using a Vega facility.
This is Vega.
This is okay. In that case where you're talking about where you could build other features that would maybe make a plot, you know, dynamic. Are you in that case then building a component from scratch and then kind of allowing it to intercept the data channel?
It's sort of like that, except that it's not particularly from scratch.
I see.
Only because, I mean, here's that slider.
Okay.
And it's because I'm using Recon. Recon has a slider component.
I see. Okay.
And it's just smart enough to do all this stuff. And it has a label component, and it has input text component. So that's it. That's all I needed to do to create that interactive slider. That was it. So it's yeah, I mean, you could do this manually, but I mean, it's a lot nicer to. One of the really cool things, really a cool and important thing. With recom, well, I mean, you can do it yourself, but I mean, React, like in this thing here, the way this is happening is each time you make changes to this thing, what you're doing effectively is scooping out of the sequence, okay, the particular frame that has all the data, and you put another one in, so it's all immutable, right? You're not actually changing any of this stuff, and then you re-render it. Okay, so what happens is due to the data flow capabilities and reagent and React, only the thing that gets changed actually re-rendered. And one of the things that's required to make that work is you got to have everything in a sequence has to have a thing called a unique stable ID.
Right. Yeah.
The React thing.
The React concept. Yeah.
Yeah. And the nice thing is that the recom components just do this for you.
Oh, that's great. Yeah, because that can be sort of annoying.
Yeah.
I know from having worked with React a lot, it's often.
This is one of the really cool things. It just does this stuff for you. Really, it's really nice. It's just like this. This is all built on recom too. So there's. I wish I knew what that was. It has something to do with the
Mac trying to be helpful.
It's the Mac trying to screw me over. Yeah, but you have this. So this is a splitter component.
Yeah.
And I just use a splitter component to do stuff.
Nice.
So yeah, it's really kind of cool. If I had to do that if I had to do that myself, I'd probably be still trying to figure out how to do it.
Right.
This is all done with Flex. Everything is Flex box stuff. Oh my God, but it just works. That's one of the really nice things about it. Here's some stuff. I don't know what this is. Let's just try it. Okay. Yeah. Okay. Here's you got a little law tag in here. Kind of nice. Mixed with Markdown. Yeah. That's kind of cool.
So can we go back actually to that previous use of recom with the slider that you were showing us?
Oh, yes. I have to re-render that thing.
I'm actually interested in how you defined it when you declared the chart. Is that so
yeah,
maybe could you walk us through what where is it? It's this bar chart, right? Is that?
Yeah, this is it. Yeah.
So you've got the data there, and then you're doing your transform like you showed us before. But and how is it that you're how does, I guess my general curiosity is, how does the recom component get added in? Is it being added to a Vega Lite definition, or is it?
No, actually not. What it is this component, the model for the component, is able to update the data channel of the associated thing. And that magic just happens over in the client. You have to build you have to see, in the client you could do this much easier. But here, this was before I had the client capability at the level that I use today. But in this case, what happens is you have this back-quoted thing here. Okay. Is that it? No, that's not it. It's this one. And
I see.
And you'll note one of the things that's interesting. The Mac got nuts. It's the only thing that works with Zoom for me, though. Anyways, where did it go?
Right there,
yeah.
Yeah, there's this model, right? And then there's this on change. On change is the function that then will update the data channels. And that has to be implemented over on the client side.
I see. See, this is a whole reagent template or definition.
Yep.
Of a recom component.
Yeah.
where you're supplying, what's the OC2 there? In the, what do you?
What happens is that's just a little piece of magic communication between the server and the client. And what happens is over on the client side, there's one of the things you can do with Hanami is you can supply a transformer for any given message. And what happens here is it gets run past this slider definition, and it turns it into the actual active component.
I see.
Yeah, and so
essentially, the slider and the graph are connected to the same atom. So once you update that file, it's going to be done.
Yep, that's exactly right. Yep. Yep.
Cool.
I don't know what this is. Some of these are kind of cool in the sense of what you can see. So that's in their picture frames. Yeah, this is just showing you this grid layout with each board of a picture frame highlighted. So here's the top, this is on the left, bottom, right.
Yeah.
The same picture, same graph. But it also sort of, shows you how you can just map. You can, a lot of this you can just use Clojure to do. It could just generate
nice.
This stuff.
Yeah.
And it just whoosh.
Right. That's your stream of charts.
Exactly. Yep. Yeah. Here's one that has, maybe this is just text. I don't remember. Maybe it's an empty frame. No, here's one that just shows all four. How you can do that. Yeah, and you can even do this kind of stuff. And then you can pop, get this, goes over there. Yeah.
Very nice.
Yeah, so that's, I don't know if this is active or not. Let's see if this works. So this looks like a piece of actual real live data. Oh, wow, here we go.
That's some gene stuff.
This is, yeah, exactly. It's a tRNA evolution experiment, really, is what it boils down to. Who survives better than others?
Right.
But you can also see, we can just flip.
Yeah.
Takes a little bit to render that one. That's quick. This is, well, it's still pretty fast.
Yeah.
Yeah. But you can see how you can just create a document. And if you're doing something more organized, all of these would be like different chapters of stuff that you wanted to show.
So every time you switch tabs, they get re-rendered every time, right? Every time you switch tabs,
every time we switch tabs, what's going on is the body for this is being put up. But I think if you look at the logs for this, not much is actually being re-rendered.
Okay.
Almost nothing. And that's due to this reagent react magic.
Yeah. I think it's just hiding that div and then showing the other div.
It's something like that.
Display, display changes.
Yeah.
By the way, so once you create this whole interactive document with all these tabs, so what is the reproducibility step? Like, how do you save this and reload?
Yeah, well, that's what these buttons are about. The idea is you would just save the document, and since it's all of this stuff, all of these tabs and their content and everything is just data.
Yeah.
And so saving it, the idea here is what it does. You have to have a server connected. You have to have the server connected, and then what it would do is take that current set of sequence of data and just send it to the server, and then it would save it in a file. And then on load, the idea is you would just read that in, send it over to the client, and then call the update function, and it would just.
Okay.
So if you hit download, does it work now, or is it this a future feature?
It isn't quite there.
Yeah, but you would save a file.
Yes.
on your from that, and it would
Yeah.
be some sort of data representation of the whole
It would
layout,
actually,
multiple tabs and all of that.
yeah.
Mhm.
Yeah. I don't know. I might use Nippy. There's some more. I'm experimenting with some of it because if you have a huge data set,
Yeah.
amazingly enough, it's not really that bad. I've had examples of some of the stuff on scicloj stuff was like 50,000, 70,000 points and overview plus detail, like that area chart. Yeah, and actually I used the exact same area chart capability as what was shown here. So again, you can just abstract over this stuff. I don't know. Anyway, it's surprising how fast it goes over. It gets over to the client in like only like a second, maybe not even. And then it takes a little bit of time for it to render. But it's surprising how well that works. Anyway, so I'm playing around. The other thing is like, where should it save it?
Yeah.
That's this idea of having a .saite directory under your Hilda directory. So where you could configure, like where are you going to save these documents, and also if you know how to load them and all that kind of stuff. There's a lot of junk in that regard.
Yeah.
I mean, you can do this kind of stuff, which is it's always kind of neat to see. I don't know where that is. It's probably over here.
In the lists. Oh, yeah. Wow.
Now, the only thing is this is why I mentioned using Cytoscape. I was adding Cytoscape. Because even though this looks pretty cool, there's a couple of things. There's not much you can do interactively.
Yeah.
You can't click on a node and have a bunch of stuff show up that's inside the node. The other thing is you can't put the labels in the node. And the other thing is you can't label the
edges.
The edges, yeah.
Edges. And I specifically asked the team about that, and they were like, "Nope, can't do that. Low priority. You can file an issue." So I was like, "Oh, that's good, but probably should just maybe use Cytoscape." Yeah. I guess that's, I don't know, that may be about it for today. Unless you guys have more questions, I can talk for another 10 or 15 minutes.
Okay, I was thinking that it would be cool to actually send that full data representation of a document, or at this point a dashboard, I don't know, could be sent via a network. So I could have this on one server or a computer of another person and just send, I don't know, every day an update or new stuff over there, and they can just find it. And it would be already done, basically.
The picture itself or just the data? Yeah, absolutely. You can just send, one of the things that's really nice about this, even like this tree layout thing, I think is the URL. Well, it's a web URL, but you can make that a full, full URL. And you can send this vector over to, by mail to somebody, and they could just pop it in and it would just display. I mean, another idea is I thought about this too. There was somebody who came up with a neat thing with GitHub pages, I guess is what it is. And there was a fellow who has a thing about how to have a closure script GitHub pages. And I talked to him a little bit about how when working with his client. He didn't have any server, but was still active. Had so all of this stuff in here and in here, all of this is self-hosted ClojureScript.
Yeah.
So that's how it's working. And he was like, "Yeah, you ought to be able to do that. If you did that, then if you just cut and pasted something like that into a client over there on GitHub page, it would just display the thing.
Mm-hmm.
So I'm thinking about doing that too, but I don't know. I think the save thing is the thing I want to finish.
Mm.
Yeah. I mean, the way I did this before is it was over on the server.
Yeah.
I mean, if you put a gigantic do around these things, as long as they were separated out into, say, different tabs and weren't writing over each other, right now I'm just sending to the exact same tab and not adding. I'm just replace content. But if you just put a do around all this stuff and then evaluated it, it would just recreate the entire document. All the tabs, all the content, all and that's the way I was, quote unquote, saving documents. It was just basically Emacs editor files. Yeah. But if you're going to have this kind of interactive stuff where you're fooling around creating documents interactively, you need some saving on the content.
Yeah.
Yeah.
Are there other export? I wondered if you mentioned that earlier, like, to like some sort of more static form. I see. Oh, right. Yeah.
The other thing I was thinking, is when you do this save, one idea I had was there would be maybe an option of the save. And suppose you had, they're gone, like a thing with a dozen, like 2 dozen charts or whatever. One of these, these are all just single. Oh, this one has 4. This one has. One idea is that, again, you can configure what directory to put it in or how to structure the save thing. But the idea is it would basically do these saves for you. You could say, okay, save all the graphs as PNGs with their associated name.
Yeah.
And maybe you have there's a directory, which is the chart save directory, and each subdirectory in there would be a tab name and everything. And maybe underneath. That's something I didn't actually show. One of the things you can do, again, very dynamic, is this thing here, this title of this. If I log in, if I were to log into this thing, say from another machine, as long as I'm the same network, and type in this Saite interview as the session that I wanted to interact with, then things that anybody who was logged into those things, they would each see the stuff happen.
Oh, okay.
Yeah. I've used that a couple of times at the school. There's an idea of being able to have it so that everybody can have their own session and people can log into each other's sessions to see the kind of visualizations they're doing.
Yeah.
Yeah. So it's all very dynamic. So effectively, it's just a subscribe, publish.
Yeah.
Yeah.
Nice.
Great.
So maybe that's it.
So the Hanami thing can be used as a library, and then I can embed that into other applications. And then Saite is the whole application that you just showed.
It's an example application on top of it.
Yeah.
But it also now has all this other stuff. It's not just. I mean, some of these other things are just Hanami. They're just, that's all it is.
Yeah.
And, with things like, recon components.
Yep.
Like for the, I guess we lost the bar chart. Well, recon components for things like drop down for experiments. You select the experiment, and then you get to browse through the visualizations of that given experiment.
Yep.
Stuff like that. So it has some recon components, but it's all fixed. It's not like you can add new components. It's just a one-off application that does that kind of stuff. And so that's built on. Doesn't
Okay.
have any of this code mirror, doesn't have any Mathjax, doesn't have any of that stuff.
Yeah.
It's just,
Yeah.
I mean, I really liked the you know, many of these things here, but the transformations piece just seems really closure-y, and that it could really speed you up around, you know, I mean, I was messing around with Oz in a notebook context. You know, it'd just be nice to not have to write out the whole declaration. You know, I wasn't even doing particularly complex ones, but it's, you know, and at the same time, it's not, it's better than the kind of Python thing where you might have like a, you know, line chart function, because in the end you still get a data that you can inspect,
yes.
look at, modify, you know, it's a very nice.
I mean, that's exactly right. I mean, well, let me quickly see if I can quickly do this. Oh yeah, you're right. Because here's an example. This, I mean, here this is Altair, which is the official Python way to do things.
What's that library called again?
Altair.
Altair.
Yeah.
It's actually referenced in here. It's clickable reference. And yeah, so this is their official example of the scatter plot, which we've already seen a couple of times. And here's the same. We've seen this already.
Yeah.
And this, so this is the same as this, but it has this. It's really an advantage because now it just turns this stuff into, it's just data. It just
that's really nice.
Thing into a concrete data.
Yeah.
And that's it. And so, yeah, here we've already seen this before. Here's the transformation. Right. And when you send that, it gets rendered.
Yeah.
Yeah. The other thing is Altair can't do Vega. Whereas, like, well, yeah, I mean, here, let's see here. Well, this is the instrumented bar chart. It kind of explains how this works. Yeah.
And if you were to run, let's say we're in a notebook context, even though we were talking about how we don't like those. Let's say you used Hanami in a notebook context and you generated the data that, you know, the template using one of these transforms, and then you wanted to render, you'd be using, what would you use for that? I presume that would be possible, right? Then would you just use?
You mean like, if you mean embedded in Jupyter or something?
Yeah, like I had used in some, you know, in a tutorial that I was working on for scicloj, I was just, you know, rendering some, you know, an experimental data set or you know, an illustrative data set with Oz. And so generated a Vega Lite template, I guess you'd call it. And then Oz had a rendering facility.
Oh, well, yeah, this definitely has all that stuff.
It has all that. It's what's the Hanami equivalent of it's like, because you had in this other context you called SV exclamation, like, which was a send, I guess.
Yeah, we go down here. So here's the API stuff.
Visualize, I see.
Yeah, and then there's this.
Right. It's a vector, I see.
Yeah, and actually you can do more. It depends on how low level you want to go. This is an actual recom reagent. Not recom, reagent component.
Yep.
Nice.
There's an example of that. Let me show an example of how that works. I'm about out of time. Let me see though. let's grab this, our favorite ridiculous point thing. Go away. What are you doing? You're hiding what I want to see. So if we go back over here, can't get the Mac to do the right thing. I have to literally do Command C. All right. So now I can translate that. Here's the JSON that turns into.
Wow.
Cool.
Okay. And then with a little bit of luck, there you go. So this is the magic of recon again. These modal panels with scrollers and so if we take a quick look, this is the wrong. There's the React tab. Why does this small? Here's the component for the double arrow tab bar. And inside of this, it's how all of this is being done. And one of the things it calls is this visualization panel. And here you go.
Oh, that's your VGL function.
Yeah, this is not using any Hanami machinery, tabs, or visualization list, or anything. But it does make use of that component, that VGL component. And so that's how it pops this up. Because this whole thing is in a scroller, and here's the modal panel. So there's the entire thing to make that work. Yeah.
Cool.
Nice.
Yeah. So there's a lot of. I'm just going to update it with some new stuff. But, questions like that. This is all here. You get this table of contents. Here's all the junk, and it kind of goes client-only applications. How you do that? There's a fair amount of this stuff in here. There's all this picture framing. Examples.
Very nice. Yeah, it looks like there's a lot to dig into there.
And here's one other thing that's kind of cool. I don't have this on this machine. Here's some examples about when you were saying about how it abstracts and it cuts down on all of the stuff. So here's a layer chart. Okay, that has this lowest thing. This, okay, when you transform it, turns into this.
Right.
Okay, and that's the stuff you'd have to write if you're writing Vega Lite. And it turns into this. And then, doesn't take much, just add this one little blip. And now you have an overview plus detail.
Yeah, it really allows you to focus on the pieces you need and abstracts away the boilerplate kind of stuff, it seems like.
Absolutely, completely. Here's another one that's a completely interactive cross-plot differential gene thing. So here it is. That's about it. And then it turns into that. And yeah, so this is a fully interactive thing.
Yeah.
If you highlight things over here, it'll highlight them over on this side. And
What is this is a more general question. I don't know. It's like, what is the status of Vega and Vega Lite in the kind of visualization space
I think
alongside something like D3, which obviously enjoys a lot of popularity?
well, D3 is from the same people.
Uh-huh.
And Vega, one of the engines it uses it exclusively targets D3.
Oh, I see. Huh.
So Vega Lite compiles to Vega, and then Vega itself compiles into into a runtime environment. D3 being one of them. There's an experimental WebGL version of other stuff to make it faster, but
interesting.
That's how it works. So,
So isn't Vega essentially like a visualization grammar stuff or something like that? Like it's a language to describe visualizations, and then
Vega is basically Vega is very much like a grammar of graphics. As the ggplot. Yeah.
It's like I sort of understood it. It was like, whereas something like D3 is very, kind of imperative.
Yep.
Although, the Vega allows you to think in this.
Imperative way.
Yeah, absolutely. This is this kind of, if you go over this conference talk.
Mm-hmm.
It's a pretty neat video that kind of gives you an overview of D3, Vega, Vega Lite, ggplot, grammar graphics, and where they're coming from with all this stuff.
It's a good tip. Yeah, we should.
It's
it's that Vega context is really important here, obviously.
Yeah. Yep. It would be really cool to see a WebGL version of it that actually released. I mean, it really, like, for example, this thing here, this is a good example. This one, and this thing, there's like 50, 70,000 points here.
Right.
Wow.
And it takes, rendering isn't too bad, but when you start
clicking and then adding interactivity.
The brush to do this overlay, this thing here, and start moving it across. It's pretty slow.
Yeah.
Pretty slow. Yeah.
Cool. Okay.
So do we have more questions, or what do we want to do here?
No, I don't think I have any questions. Alan?
No, I'm okay as well.
Cool. Well, it's really nice to see, like a Vega bindings, and I've seen this conference talk a long time ago about Vega, and it was pretty impressive. And mostly I was doing D3 related stuff a bit, but this seems like a really nice way to, and as I think Nathan was pointing out, the notebooks are like they have this modality, and there is this weirdness in that one. But I like your idea of using that concept and extending it into a more closure way.
Yes, I mean, this is very REPL-y, or here, all in one kind of a place. Especially with this example, we were rendering all these things dynamically. And
it also kind of reminds me of RStudio a little bit. Where you've got that left-hand side, and then
that's a good point. Yeah, that is a good point. But last time I did anything with that, though, it was the plots were static.
Yeah, that's right. I think they are. Yeah. So this is much more.
Whereas this, this is just a minor thing with tooltips. But I mean, you can have fully interactive things here.
Right, and the grid layout gives you a lot more to work with there.
Yep.
Yeah, it's nice.
Okay, so I think we're right on time.
Yeah.
Perfect.
Yeah, I hope this was worth it.
It's been great. This is it's really interesting. I think it's it really is a good opening talk. I think it give, you know, both in terms of what you've done here, also the relationship to these, you know, different the way working with Clojure data science may open up different possibilities and ways of working. I think it's a really good introductory, or, you know, or a starting interview for us.
Yeah,
my sense. Yeah.
I
So
mean,
thank you very much. Yeah.
Oh well, you're welcome. It's great. My pleasure. I think what would be really, really cool when I get the you know, Neanderthal plugged into this.
Mm-hmm.
Yeah.
I think.
Yeah, that'll be fun to see.
Yeah. The other thing I believe, I'm not 100% sure, but I'm pretty sure that I can get it by bundling the MKL libraries.
Oh.
Get it the CPU version of it.
Yes.
Turnkey kind of a thing. Where people now have problems setting it up just because they got to go get those libraries and put them on the library tab. People don't understand a lot of that.
Yeah.
But it would be cool to be able to have, you know, crunch 1 million data points in a couple of 3 seconds and then plot the thing over here. That'd be kind of nifty.
Yeah, given the amount of GPUs that we have these days on the laptops, then it's going to be super fun to do that. Yeah, yeah.
It's surprising how fast the CPU is.
Yeah, exactly.
Yeah.
Nice.
Well, okay.
Thanks, John. Thanks a lot for the stuff, and I think we'll keep in touch on Zulip, I guess.
Okay.
Then good luck with the Neanderthal thing.
Yeah. How do I get out of this?
I think we can just close it. I think
out of the chat. Yeah, you just kind of or you close the Zoom window.
How do I close the sharing?
Click on the share thing. I think
pause share.
Yeah.
No, it's only pause. It doesn't actually get out of share mode.
Yeah.
I don't know.
All right.
Yeah. Anyways, whatever.
Yep.
It'll be done for sure.
Well, we can get out of the call then, and the share will stop anyway.
That's true. All right. I'll talk to you all later.
Talk to you later.
Bye.
Thank you very much. Bye-bye.
Thank you.
Thank you very much. Bye-bye.
Bye-bye.